Okay. Let's see. I think we're good. I think I'm coming in straight hot this time. So, yeah. Hi. How's it going? Nice to see you again. Welcome back. Hopefully, let me get my monitor set up good and strong here. So you can hear myself? All right. We are here. We're good. No, I am not good. You can see my terrible, terrible messy basement here behind the screens. Let me fix that. No. Sorry, my setup got a little bit messed up when someone lost my mount for my camera somehow. Not gonna say who. I haven't been able to find it again. So I've been using like a hack mount. And sometimes I bump things and things move out of the way. But anyways, whatever. We're here. We're good. We're back in action. It is the best time. It is the worst time. It is the okay time. We are going to continue our adventures to build a roguelike type style game thing based off, it's a kind of a roguelike based off of, inspired by Star Trek, based off a much older game. Nerds have been doing this since like the 70s. A game called, I think it was actually originally called Star Trek, but it's also, there's also one called like Super Trek, and it's many variants and clones over the years. If this is your first time tuning in, welcome. By the way, nice to have you. And this is what the game looks like. So the idea is that you're flying a spaceship, you know, around in a small section of the galaxy, and there are a bunch of invading enemy ships. And you have to use your resources to defeat all the enemy ships before you run out of turns. You have a certain time limit to the game. There's a time pressure to it. So this is what the game looks like and where we're at so far. I think we have like kind of the basics of combat coming along pretty nicely. All right, this is our little game area here. This S is our ship. This little $sign is a space station. We can like recharge and dock there and recharge some of our resources. Not our turns. This is an enemy ship. Has like a little star. All right. And you can, you know, shields up, move into combat. We have like a little dialogue area here, which is pretty cool. Move into range here of the enemy ship. They're going to fire on us a little bit, but our shields are going to absorb some of the damage. Alright, so our shield strength's gone down. Took a little bit of hull damage there. We can't fire our phasers through there, but we can fire a torpedo maybe. 8-3. There we go. Boom. Torpedoes insta-kills. We only have a certain number of them. Now we can dock at the space station. We're good. So as we have so far, last week we started implementing the next level of this, which is to be able to take this, to zoom out and warp to different sectors of the quadrant, or different quadrants of the sector. I don't know. I'm getting the terminology mixed up as we go along from like the Trek canon. So if you're a Trekkie, I claim to be one, but you might not believe me. You'll just have to deal with it. And maybe somebody will fix that someday. I don't know. Anyway, that's where we're at right now. That's where the game is. And let's get going with the quadrant stuff. So let's see, the simulation, quadrant, sector, all that junk. Let's get our builder going. Oh, I needed to fix the tests first. So let's do that first. I don't think I actually worked on this between streams very much. Or at all. Yeah. Test, or the test like that. Fast. Just byte compiles everything instead of like does a full optimization pass. Which just tends to be faster to compile, and we'll use the file launcher as we usually do. So I'll just rebuild everything, rerun the tests after every file change. is a little dry here today. Ugh. Okay, so let's see. Yes, we just have a bunch of like kind of annoying type errors with the test library. And maybe we'll spend a little time fixing up the test code, because every time I go to make a change to like the game state structure, the tests break because I'm like using the bare constructors directly a lot there. And that's starting to get, which is fine like with a small amount of code, but it's starting to get a little annoying. So I might want to make some smarter constructors there to like kind of hide a lot of the implementation details so that I can change them without breaking the tests. What am I doing? I'm going into the test directly. Go open up the test. Spec. Bang. Okay, going down the list. Let's see. Anytime we see enemy ships. 318. Because of the way we changed the implementation now of the state structure, which is all exposed in here, this is all breaking down. So in this test here, when in the fighting state, it should transition to patrolling when the player moves out of range. Okay. So we execute the state. Well, this game command was engine move. And then we get the enemy out of here. But this is no longer an array of enemy ships in the game sector. So the way we change that was by quadrant. So enemy ships are now in an array in this map. So maybe we have this handy dandy get sector. With the sector chord, which we get from the current state. It would be pretty handy to have these functions on the game state that can like reach into the game state, go get the current sector coordinate, go into the quadrant map, get that sector, you know, and pull all that out. That would be super sweet. Let's just get these tests passing first, and then maybe we can press something like that. That might make our test code better. Okay, so we have to get the sector first. So let's do that. We gotta get. We use get sector. We gotta give the quadrant, which is the final state. That might be game state quadrant. Like that. And in this case, we know it's going to be at 0, 0, because I think that's the way we set it up. Although the proper way to do it would be final state or game state current sector, I think was the name. Something like that. Oh, maybe I just game state sector. I think I might not have renamed it. And we should do the same thing for up here. We'll call it final sector. And we'll call this initial sector. I'll just pop that up there. This will just be initial state. And then the array elements can just come from initial sector. Oh. Nope, I'm doing it wrong. Hang on. That comes entirely from the quadrant enemy ships. Oh, no, no, no. Get sector does construct the sector, which does have the enemies around it. Yeah, that should be fine. Yes, and then this same thing. And this should... I think this should compile. Nope. It's a function still. Get sector. Yeah. Yeah. Let's look at the game states. Yeah, sector is just basically a tuple of 2 and 0 vec 2, essentially. And that should fit into that slot. Vector enemy ships. So it thinks this is a function with this type. Let's just add our getter there. Okay, oh, I was probably just using record.syntax for reasons. Which is also very handy and useful on a recent addition to Haskell that is definitely worth knowing. Hey Cypher, how's it going? Do I use arrays in the state for cache locality? If so, could we improve things further by unboxing the contents? Kind of? Yeah, that might have been my initial instinct and kind of just what I did subconsciously with it. Yeah, we could get a little more clever with it. And still maintain all of our interfaces, for sure. Yeah, and like, really, we could even unbox things a little bit further if we want to. Like right now, this is an array of records, but we could... This is just a projection. The sector is now just a projection off of, from Quadrant now. Where we have like these arrays here. And we could probably even flatten this out even further. To get better, even better locality if we wanted to, for sure. Okay. So, Tina. Thank you. Where did I miss this? Initial state. Word wrapping. Intitial. Yeah. Oh, I know, Cypher. I know. Thanks for watching and hanging out with me tonight. Okie dokie. 303, we have enemy.state. It doesn't know what the enemy. Oh, right, because we have to do the same thing here as well. Sector, yeah. And then we use the initial 8 quadrant and the initial 8. Okay. And then this becomes and that should fix that one, hopefully. Oh, that's gonna happen a lot, isn't it? Intitial. Initial. Yes. So now that's the problem. Yeah. This is what I was hoping that this meant. This, but now Haskell can't figure out what the type of that is. Oh no, that did it. Okay. Oh, that's annoying. I have a lot of annoying use of these generated has fields instances that I thought would be nice, but I'm having to like prefix a lot of my module names because like it can't figure out which has state class I'm in, or has star class. This pattern is going to be the same here. I think we got another one. Bazoom, and do like that. Super. Okay. The next one on 111. Cool, and next state. What was this one? Okay. I messed something up with the test here. That's no good. What was it before? I messed things up. Okay, it was getting it from the next state. That's what I was messing up. Do I know how to turn on closed cabinets? I don't know if Twitch has something like this. I'm going to try and see if I can find this now. Let's see, clip settings, permissions, raise, drops, and rewards. You know, I don't know, actually. This is something I've wanted for a while. So, okay. There might be something I have to turn on my side. Right. Okay, that's what I need to know. Twitch. Closed captioning. Let's figure this out. Oh, okay. I have to actually do... This has to be a thing I have to set up and like do. I guess. Interesting. I have no idea about all this stuff, but I'm gonna learn. For viewers, yeah. Okay, so for broadcasters, I've got to transmit stuff. Okay, I'm transmitting that. Sounds complicated, but I'm going to figure it out. Yeah, that would be cool. Because, like, there are some... I was hoping it would be as easy as, like, Google. Because Google has that nice, cool, like, live captioning service thing that it does. It isn't super accurate all the time, but I think that's better than the nothing we currently have. Thanks for the bump. Okay. I will attempt to be a little bit more enunciated and louder if I can. Okay, so all I messed up here was just selecting the wrong state to get the enemy from in my paste. We're going to get from next. And then I think that will make that better. Sorry, not next sector. I forgot to change this one. Okay, there we go. Okay, one less test failure, so I still messed something up. Probably did something similar in another test, in that other test there. Yeah, where I probably didn't mean initial in this example. Probably meant next. One more time where I messed it up and I wasn't paying attention. There we go. Okay, good, good. Let's get rid of these errors. 279. They're just warnings, but they're good to pay attention to them. Not let them, don't let them get out of control. 279. Not used. Probably means I have an error here, and the test shouldn't be passing, but it is. Uh-oh. That's bad. Which is why you should pay attention to your warnings. 293. Yeah, there we go. Okie dokie. There we go. Now we're back. Sweet. All right, I do want to fix this code so that I'm not using the constructors directly and stuff. Because every time I change the structure of the state or the underlying implementation, the stuff I talked about at the beginning of the stream, it does tend to kind of break a little bit, which is pretty annoying. I don't know how exciting that kind of work is going to be. So let me just bring my windows back into where I like them. Okay, so yeah, I'm going to commit that. Now, let's talk about the quadrant UI. That's what we should do. Let's go into our UI code. We're using the wonderful brick library for Haskell. A nice it gives us like a nice declarative kind of interface library where you can just declare the shape of what you want, where you want the things to be rendered, and behind the scenes, the library kind of does all the procedural stuff to figure out like what the terminal width is and how to fit everything in there, which is pretty handy. So we're going to need a way now for us to bring up the quadrant map so we can do a warp command. Now, how should that interaction work? I feel like we should either have a key press here that switches to the quadrant screen, or have another command? I think a key press would be nice. I feel like I want to be able to press like a modifier key or like an F key, F1 or something like that, and that'll switch it over. Yeah, let's do something like that. So I'm going to bring up the library documentation for Brick. I think it's under VTY, the key code for handling F keys. I don't know if it's in vty.image. Input events. Let's see here. We get escape, card, KBS, enter, left, right, up, down. Oh, K-Fun. Index from 0 to 63. Range of supported F keys varies by terminal and keyboard. Cool. So we get K-Fun with an int that tells us which key it is. Super. Okay, so this is our main UI definition. Our application does the event handling from the UI, I believe. Here. So we get VTY event, key fun, X1. We should do something. So that gets the state, the state that we define that Brick encapsulates. And we want to, what do we want to do with that? I think we want to change something in there. Screen, the game screen. Yeah. We have a game screen variable here. We have a sector screen, so we'll need a quadrant screen. Okay, and then all we have to do is set the quadrant screen. So then we just have to return the form state modified. So we can just use modify directly. Something on S. EV key. This one might need parentheses. And a list that we don't really care about. Okay. No, we don't want that. Right. We want to... What do we got to return here? Something in event M. Maybe we got to put the state back, modified state back in this case. If we did nothing. So I put... Would that be fine? Mm-hmm. Let's put a hole there. What do I have in scope? So we want a foreign game state E name. S is a game state. Okay. Maybe Brick gives me some combinators that I've forgotten about that allow me to manipulate this. Skadoosh, 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 skadoosh. Go up there, look at view, click bot, cursor management, rendering cache, render internals, no, nothing like that. App type. This is where we got have event, start event. Draw. Oh, really? Huh. Good thing you don't use this library as well. That would be very confusing. We have a similar problem at work where we use a pattern called event sourcing on the back end. And so we have a bunch of types called like events. And there's different types of events. But then one of our integrations with an external service, they changed their API to also serve entities they call events. And so there's a lot of this word use of the same word, event, everywhere. And it's you have to really be careful about which one you mean. Okay, so my state. Oh, it uses Lens Micro MTL. Sweet. That's nice. So we should be able to use that in our code because that's what we use. We do end up with super verbose names sometimes. And just downright confusing ones. Yeah, it's pretty bad situation to be in. We have like blah 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 event type event thing. No, the actual event thing and stuff like that. It's ridiculous. But these, it really does confuse things too when you're trying to understand like how this system works, especially like external systems. Like names do matter in like just when you're writing about something, right? And you're trying to keep things straight in your head. It might be tempting to use a very generic name like event, because what else could it be? But when everyone does that, and then you're trying to integrate them all together, you gotta. It's just noun soup, crazy. I shouldn't say crazy. It's just not good. It's just not good. Okay, so we can use micro here, which would be great. So we can get the game state. Use game state. Oh, editor. Because they have. Okay. So we can zoom in maybe on the game state. No, it's not a record. We could just set it directly. Although I don't know if this is a handler for. The best naming choice I've seen in Haskell I found when I was researching this. Unsafe pointers in functional programming. Yeah, seriously, unsafe object address. Yeah, there's like in the byte string library, I think there's like unutterable unsafe perform IO as well. Like, don't even speak the name of this function. It's terrible. There's some good ones, but like I think that actually surfaces a lot in Haskell, which is kind of nice too as a programmer, so that when you're reading someone else's code and you're trying to maintain their code, it's like just little flags that you leave here and there that you're like, this is unsafe, and then you know, like this whole block, you really have to pay attention to everything that's bound in its scope and stuff. It's good. I like it. It's a good pattern to use. I think we could do game. We set the game state screen to be equal to the quadrant screen. Is that not right? Because we're using forms, maybe? I'm really enjoying using the micro lens library. It's so great with MTL like classes and using it with state especially. Super awesome. But for some reason I'm running into this form thing, which I think has to do with forms. It's just slightly smaller than the regular lens library, so it cuts out a good chunk of functionality that so far I haven't really needed. So it just, especially if you're implementing libraries, like, and you don't really need a dependency on lens, like, don't make your people compile it. But this, for example, this brick library uses it, which I think is smart. So it's still like very much the same style of lens. It just cuts down on the amount of stuff it exports. So it's just the bare essentials. So like in the core library, it's got most, like a very, very core essential. Like this is a very tiny library. And if you want to use like the state stuff that we're using on the state monad, that's in a separate package. Right? Whereas I think the main lens package, the big one, the Comet one, like includes everything. And I always know that I'm like using a library that uses it because like you wait for your compiles and then you hit that lens dependency and it's like, okay, we're gonna be here for a while. Let's go get a coffee. Yeah. Import lens.lens is the time to go get a coffee for sure. Whereas this one's much, much, much smaller. So the amount of lens that I use, I feel is like a good sweet spot, which is just a little sprinkle. It's nice for working with like deeply nested monads and graphs of things. I don't use the traversals a whole lot, if at all. And prisms, not as much. Except for maybe the basic ones. But I'm not doing like funky list stuff and things like that with it. Okay, so the form thing is what is getting in my way from using it. So I'm going to do this. So this might be a place where you actually have to traverse, maybe. Because our state is wrapped in this type here, form. Brick.forms. Okay. Okay. Yeah, so they provide some helpful lens combinators there for traversing this thing. Neat, neat, neat. Okay, we don't need mouse support or anything like that yet. Okay, so form state. Maybe there's a lens for that. To focus on it. Nope. Come on, Brick, what do I gotta do here? Update form state, maybe? Maybe that's what we want? Okay. So that is a form with our game state in it. I was like, this is so easy, and now I'm like getting tripped by a plan. How did I do the run command parser here? Maybe that's quick. That's not a very interesting choice. Okay, well, maybe it's just plain old modify something. S. Okay. Oh, okay. I think I get it now. What? Let's do it. Okay. Form state here. Okay, so we have a whole form game state E and name to form game state E and name. So we compose with update form state and our function, which changes the state. And then we pass in S. Okay, there we go. Now our function's game state to game state. All right, sweet. Back on track. So this is where we want to... I'm just going to write this out like the way with a lambda. And we want S. And we want to set the game state screen to be the quadrant screen. Is that the right one? Oh, ampersand? S prime. Okay, yay, compile. Green, super. Okay, so now when we press F1, we should be able to do that. Let's change the UI a little bit so we can see this effect happen in the UI. So we go to render. Game screen. We do quadrant screen. We should do something else. Let's just do let's just do quadrant. That'll be our widget. Okay, that should compile. And when we run it, there we go. I'm going to press the F1 key. And there we go, straight over to quadrant. And now, of course, I need to be able to switch back. It's not quite useful to stay there. Let's add a key handler to switch back to the sector screen. So that's F1 to go to quadrant. Let's go to F2 to go to current sector. Or the sector screen. There we go. And just set it back to sector screen. Cool, that builds. Now if I press F1, I go to the quadrant. F2, I go back to sector. I can flip back and forth. Nice. Like it, love it. Okay, let's make it better. Add toggle, switch to quadrant UI, F1, switch to quadrant view, F2. What is the type variable E in the event handler? We'll get to, I can show you that in a second. To sector view. So here or in the UI? In the UI, this E is the event type from Brick. So actually, we're looking at form. Right, form, game state, E name. The name is a label. E here is the application's event type. So you can define different event types that you want to handle, like key events and your own custom events. And they can be passed through using that type parameter. That's how I understand it. Hopefully that's helpful. Okay, so the quadrant screen, we want to have similar setup to the sector screen. I still want the info panel, the border, the command palette. Might want a slightly different info panel, depending. I think that's the gist of it, yeah. And because the user can define, you can define as the user of the library some event types too. ones, so you can match on all of them. I think they get passed all the way through. So I'm pretty sure you could really push this UI library to do some pretty neat stuff, just straight from the terminal. I don't know why, but you can. I like using this library because, like, it's just a quick way, especially if you're doing like roguelike game developments, which are very, very classically in terminals and developed for terminals. Although I think a lot of the movement is towards graphical UIs now, with like emulated terminal feel if you still want to render it to look like a terminal. But it's also just like a quick, simple library to get started with. I think the abstraction and structure is pretty nice, that this could be ported to, if we really wanted to take on as a project, to port it to a graphical renderer as a backend rather than the terminal. I think that might be possible. Okay, so I don't have a UI called quadrant screen. Let's go define that. I do have one called sector screen. It's going to be form, game states, something. We don't really care about the event. Widget. That's what we have to return. We want quadrant display. I want to get the game state out of the form. Okay, we have defined what quadrant display is. So let's do that. Now, if I wanted to have quadrant display react to form and like UI events, we could do that, but by not stripping off the form state from here. But I'm just rendering stuff. I'm just drawing stuff here in like an area. I don't really want to do that necessarily. Okay. So, quadrants. Quadrants now are maps. This is a giant map of sectors. In a typical game of LambdaTrek, I think this is 8x8, if I remember correctly. The typical like sector game map. So again, I've flipped around the terminology between quadrant and sector. So in LambdaTrek, I think when you see sector, it means like the big sector of space, and the quadrants are the little areas that you zoom in on, where you blow up other ships and dock with stuff and things that we've been doing. And then to do a warp, you have to give the delta x and the delta y, or automatic. In quadrants, displacement of one sector is 0.1 quadrants. Yeah. So we're going to do something similar like this. Let's just make it 8x8. We'll just say 8 sectors. That'll give us 64 sectors. Right. It's pretty good. It's a lot. That's a big chunk of space to simulate. Or we could do it smaller. Do 4x4. Maybe we start small. 4x4 sounds good. Okay, so in order to render the quadrant, I haven't really thought about what I want to render on it either. This might actually be fairly static. The quadrant map isn't going to change, except unless we want to show like some... Well, the other thing with LambdaTrek was that you had long-range scanners. And so from your current sector, you could use the long-range scanners to find out information about the other quadrants in the sector before you warp to them. So if you want to know where some enemies might be hiding, you would use that on this screen. We don't have that yet. We haven't implemented that yet, so let's just go simple and just render our 4x4 grid somehow. Okay. So we'll have a function in the quadrant module. And we'll call it quadrant, build quadrant tiles, or build tiles. From the game state. And we'll let bind that. We will center it, stir, it'll be a string, I guess we'll build up. And we'll have a quadrant.render function, which will take our quadrant tiles. We'll put a border around it, just like we do with sector display. And a vertical limit 5. With our dialog, I'll leave it the sector dialog for now. Might want, now that we're using it on the quadrant screen, we might want to rename it. I'm going to import that. I already have it. Oh, quadrant doesn't export those things yet. Okay, that's what that typo is. So, let's implement build tiles. That's a game state to text. Leave that undefined. And we need a render function. No, I did it differently with the sector rendering. How did I do that? Sector tiles was my structure here. Yeah, I might want to have a similar structure here for the quadrant map, so that we can change what we render in each area depending on the meta information that we want to display using like the long-range scan thing that I was talking about. So we might want to leave ourselves a little affordance here to do that future change by implementing a new type called quadrant tiles. And make an array of hints and hints for now. Yeah. I don't want to get overly complicated here. We're just trying to get like the basics going here. So then we go quadrant tiles to text. That's how we render. And we need to import that, so let's do that. Import data.text, just the type for now. We need game state. So we need to import LambdaTrek. State. Which is good there for the most part. Cyclic dependency. Ugh. Yuck. Yuck. Okay, we got around it in sector by taking the specific parts of the game state that we needed in order to build the sector tiles. Let's do that as well. We just need the quadrant. We might need other things later on, but we'll have to pass them explicitly. Okay. So then in our UI, we need to pull out there it is. Okay, and we can just return quadrant tiles. The unit array or the empty array. This one is simple. We can just ignore our argument for now and just return quadrant as we do. I just want to make it do nothing for the most part, or like what we kind of currently do, but just with our new changes here. Get back to compiling and back to green again. Take rid of that. Fix that. And I don't have overloaded strings enabled in this module. Okay, and array. I'm not a monarch, so I can't use empty. I'm empty. But I can construct one from a list. Oh, I just have data.array. Okay, I don't need the prefix here. Okay. Oh, list array is the function side. What? What? I was looking right at it too. Happens to me all the time. Memory of a fish sometimes. Okay, so it compiles again. That's great. So everything should continue working as it was before. No surprises here, except now quadrant is sectored. Okay, that's good. Okay, baby steps. I like it. Basic quadrant rendering. Okay, now let's make it a little better. So the quadrant tiles are, yeah, they're gonna be like a, oh, some kind of data in there. I don't know what yet. But we need the list, the array to be of a particular size, which is gonna be 4 by 4. That's going to be an array of width times height, which is going to be 16. Just going to double check the indices here. Lowest and high indices in the right. Yeah, so we want 0 to 16 or 0 to 15. For 16 elements. Okay, and then I don't want to have to like pull out that array in order to access each tile, so I'm going to want to have like some way of getting at the individual tiles at like a 0, 0 or 1, 1 type of coordinate system, I think. Just kind of like, I think that's what I did with sector. Right, we have a get tile function, set tile, empty sector tiles. We're gonna do the same thing. And in fact, we might find that in repeating a bunch of this code that it's almost exactly the same, except for the the one type. We might be able to generalize this. Except for here. This is array int. Right, and we represent the sector tiles as an enumeration, a bounded enumeration, so we can convert it from an enum, basically, an integer value, to a Haskell type called tile. We could probably do the same thing for quadrant tile. Although I don't know if we'll be able to do enumerations, because if we want like more rich metadata in them than just rendering like we do for the sector, we want to have like more info in there. Yeah, that's going to be tricky. I don't think we should do it with ints there and enums, just like we do with getTile. In this here. We can still do quadrant tile though. Maybe for now. Is just something that has an int in it. Okay. I'm gonna like pretty much copy this. Except our bounds here are slightly different. The data part here. I'll get quadrant. That'll be good. Sector data, no. What's quadrant data? Yeah. And 2enum is going to be the problem here. We need a different function for that. Right now we get an integer out of the array. We need to turn that into a quadrant tile. So we could literally just put quadrant tile here for now just to get it to work, knowing that we're going to change that later. Okay, we just have a parse issue. Oh, because I left the equal sign on here. And I'm just going to rename those tiles. Right, we're hiding that operator from array. We kind of need it now. Qualified. That's array, just so we can get that. It's array dot. Okay. Beautiful. And now okay. Because we import quadrant, we're just going to hide it here for now until we need it. Just so the test pass and all that stuff. Okie doke. So we can get a tile out of our quadrant tiles map. Boom. And it does nothing. Nothing useful right now. But we just want to be able to build our tiles map. Alright, so we're just gonna make this a list. Of just junky data we don't really care about. Get rid of that warning. Cool, cool, cool. Where are we at now? Cool. Okay, so now we can build a junky list of tiles. We're not really doing anything interesting in it, but now we have enough information here to be able to go through quadrant tiles, build up a text value that we can actually render. Map rendered tile to quadrant tiles. Let's get our tiles in scope here. We probably want like text.intercalate. And we'll put like bars between them for now, and we'll compose that with the map of a render tile. And then we don't need to mention files actually. Import data.text, qualified. Okay, then we just have to be able to render a tile. And we'll just we'll just show it for now. Okay. Right. Not a list. But if we convert it to one, I think we can do it with a soaks. And if we get the second element out of the association. Quadrant tiles. Okay, yeah. Oh, the second element is int. Get quadrant tiles. Oh, int into quadrant tile. Right, we need get tile. Right, so the problem here, of course, is that I'm pulling out an array, a flat array of ints, and I don't need the associations here because I'm not actually storing the tile values themselves. Like, eventually this is just going to be some kind of, like, data here, and that we need to, in order to call render tile, right, I need a quadrant tile, whereas I'm getting an int at the moment. And I can't just map over that array to construct quadrant tiles, necessarily, yet. From the soaks. Although technically I should be able to. I'm not even sure I'll need get tile at the moment. That might have been premature. Because this should be, at least for now, quadrant tile second. And we just need to drive a show. Okay. That'll work. Okay. Boom, boom. So now, when we go over here, there we go. We got quadratile 1, 2, 3, 4, 5, whatever. That's good. Progress. Okay. So obviously we don't want to render things in a flat line, right? We want to break this up into lines and render a 4x4 grid of these things. So that's where I added the chunks of 15 things. So if we break it up to a list, we can use chunks of to break the list up into chunks of such and such a size, and then we can map the concatenation of the rendered elements together and get our grid. Let's see if we can do that with our show instance for quadrant tiles. I'm going to break this up a little bit. Yeah, okay. So, before we render, we'll get the quadrant tiles, and we will break it up into chunks of 4. So we're going to do 4x4. And then we'll map over that the render function for the render tile. Now we might need to concat map that, but we also need chunks of. Where did I define that list? Oh, I just have a library for it. Data to list split. Yeah. There we go. So for each row, we render all the tiles in the row, and then we concatenate all the rows together, so we can pass that off to text editor calculate and put that there like that. I'm not saying it's going to look pretty, but it might do nothing at all. Maybe because I did concat map. Maybe I should render the whole row. That's going to be a list of quadrant tile to texts. make this, sorry, new line. No, this ought to be what I want here. Yeah. And then that's with map render tile. And render row is just yeah, and then we want to flatten it down to a list of text. No, that's not quite what I was expecting. What am I doing here? Full text to list of text. Get rid of that. Yeah, so we have a list. After we do the chunks of, we have a list of quadrant tiles. We probably want to map the render row. And concatenate all of the rows together. Yeah, I think this will work. I'm like 95% sure this one's good. Let's try it out. See what happens. There we go. Wonderful. I can flip between quadrant view and sector. So now we have to be able to render those quadrants and figure out what to render there. And oh, sheesh. Be able to warp, implement the warp command. However, we are running so low on time this week, so. Also, we're still handling commands in the sector space here, even though we're on a different screen. You might want to change that. But yeah, okay, there you go. They are for the sector view just because it's so simple. Whereas on the quadrant view, I'm thinking what we probably want here is like to have a little box with like at first maybe just a question mark in it. But when you use a long range scan command, it will fill in a little bit more information for you so you could decide which quadrant to jump to or which sector to jump to. And so it'll be a little bit more dynamic than the tiles here. The tiles for this view are just like 1-to-1 to what is rendered on the screen. So hopefully that makes sense. It's really encoded to an enum. They're really enums. It's just you can translate the integer representation of the enum to the Haskell type. So in sectors, for example, they're tiles, and they're defined here. That's all. It's just a bounded enum, so you can go from enum to the integer representation to the constructor. That's all. It's just super simple. The quadrants are going to be a little bit more dynamic, or like, I guess they're really sector tiles that represent the different sectors in the quadrant. So why don't you use that type instead of int in the rendering? I think I do, at least in the sector view. Yeah, I've tiled out render. which just renders the tile to text right here. It's just when we pull the data out of the array, it's all in integers. And so the get tile methods, for example, here uses the toEnum function from the enum class there to convert that into a tile, which it returns up here. All right, and so it hides the fact that this is just stored as an array. Yeah, exactly. So I think the next change I'm going to make for quadrants is just that. So right now it's just an int just to get the structure of the code going and moving. Now that we have that there, the next step I think for me is to figure out what we're going to serialize in there, what we need to serialize in there, inside this array to get all that chunky, nice, beautiful data. Maybe we expand quadrant tiles a little bit so that we can do more things. I think what you want to be able to do is scan that sector and, see the number of ships maybe, or the number of stars, or if there are any M-class planets or space stations or whatever, that kind of stuff. And then if you've discovered it, right, we render it in the renderer for this quadrant. And then so when we build up the tiles, right, we'll look into this, we'll translate from whatever data we store inside the quadrant tiles there, and we'll turn it into a proper quadrant tile structure that will show more information, like how many stars are in there and things like that. Has the user discovered those stars and scanned this quadrant yet? That kind of thing. So this is just skeleton code at the moment. It's not its final form. And we'll get to that next week. So I'm just setting up the basic structure of rendering it. On the stream and the way I like to work in very, very small increments. Kind of make the tiniest little possible step towards my goal. Just that makes the minimum amount of changes that I need to make to get just one step closer, even if it's not perfect yet, right? And then get that working so that we're back to compiling, we're back to green, everything's happy. And then we make the next one, right? Instead of trying to design everything up front in one big change. And so sometimes it means, I leave things kind of like defined weird or in an incomplete state. So like right now the quadrant tile is just an integer, but that's not what it's ultimately going to be. It's just enough so that I can I can recompile the program, I can run it, I can see, how it's kind of working, that kind of thing. And then, I can be like, oh, I want to change that, or I want to change this as we go along and make those adjustments as we go. Right, without having to dive into like mountains and mountains of code. So, tiny baby steps. I find Haskell's really good at this workflow, like superbly good at this workflow. If you're it doesn't take as much discipline as it does in other languages I've used in the past. So it's really nice to be able to do that. Because one of the things that a lot of people say about Haskell is that because it's statically typed up front and it does like whole program analysis, that you have to design everything up front, right? Otherwise your program won't compile because it won't type check. It's not quite true, right? As we've seen on this stream. So we're adding quadrant rendering skeleton. Okay, friends. Thanks for watching the stream this week. It's been a pleasure coding for you and with you. And all the code that you've seen on the stream tonight, it lives on GitHub. I'm Agent Ultra, your wonderful host. And I am Agent Ultra on GitHub as well. This has been LambdaTrek. So this repository lives here, agentultra.com, or github.com/agentultra/LambdaTrek. agentultra.com happens to be my site as well. I'm also on the Fediverse at the types.pl server. I'm Agent Ultra's there as well, so you can follow me there if you'd like. And if you go to the link above, it's declarative.tv, pretty cool site. They got a link to a Discord server where we have a channel for the stream. So if you couldn't catch the stream live, you can still hop over there, join the Discord server, chat about your projects, ask any questions you may have. I check it pretty frequently, and I'm on there pretty much most of the time. So yeah, pop by there for that. Of course, you can also just star, set the notifications here on Twitch. And if you're one of my European people, or you just like to follow my VODs, I back them up on YouTube. You can follow my channel there as well. And you know what to do. Like, subscribe, it all helps. Thanks again. May all your monads be free and your types always check. And we'll see you next week. I do these streams once a week on Tuesday evenings, 10 after 8 in the Eastern Standard Time Zone. So bye again. Thank you. Take care.